So over the weekend, we were holding some open houses, some of our completed specs, and the question was posed, what type of engineering goes into the builds that you're currently building? And I thought this would be a great opportunity to talk the progression of structural engineering here at Rebuild the Block from day 1 to year 10. Let's get to it. So at the beginning of our building journey as a general contractor, we used to try to avoid utilizing engineering as much as possible. And there were 2 reasons for this. 1, the cost associated with an additional design member on our team, specifically structural engineering. And 2, if we could work within the standard code compliance for engineering standards, we could get away with building at a lower cost. However, we quickly realized that without any structural engineering, that we would be limited in the overall product that we could be able to provide. This led us to moving to typically a point where we would have a beam that would span longer than 10 feet in distance, and that would typically require us to get a load calculation for a specific beam that we wanted to put in place. So to put an example to this, when we were doing some of our patio details and we wanted to do a clear span beam from, let's say, the primary suite wall to a bedroom wall on the other side of our split floor plan, creating a nice patio that was maybe 20, 30 feet long, we'd have to get an engineer in place to be able to take care of that load calc. Now, we would only pay on an hourly basis, and it would be pretty much 1, 2, maybe 3 beams at most throughout the house that we would have to get a load calc on and have it engineered appropriately. However, it didn't take us long to get to a point where we would have beam-to-beam connections. This was the second progression of our structural engineering. As soon as we got to a point where we had beam-to-beam connections, it required specialty hangers, typically selected and spec'd out through a Simpson catalog or other types of hold downs to ensure that we would be able to create structural integrity within our building envelope. It was at the time when we started including some of these beam details, both either with large spans or a hanger that was required, that really pushed us in a direction where the engineer wanted and almost required us to be able to engineer the project as a whole. And we thought that this was beneficial for our projects because we wanted to make sure they were meeting the necessary engineering details that met the overall scope of what we wanted to build, not only at that point, but in the future. This, coupled with additional requirements for our self-cert set of plans, almost pushed us in to the point where we're at now, which is basically getting a structural engineer involved from the beginning after floor plan and elevations are established to ensure that the whole house is engineered appropriately. And while many times this increases some of the difficulty of the details in which are associated specifically at concrete and framing, we feel that it's worth it, even though it sometimes takes additional time to be able to get these details right. And I'd like to talk to you a little bit about this while we're on site at one of our Scandinavian-based designs to discuss some of the hold-down anchors that we have to put in place soon after we pour our footings. Let's go take a peek. So to illustrate some of the engineering details, I didn't really want to pull the plan sets away from our concrete professionals that are on site, but we're talking about some of the HDUs that are utilized within our homes. And we're back here on the back patio of this building. So this is a covered patio and has a wing wall that comes out that helps create shade in the area and protect it. And that space is going to be right here. As you can see, this would be all outdoor patio. But one of the details that we want to talk about is how we're able to actually incorporate this into our footing plan. So as mentioned, now that we have a full-blown set of engineering, I want to talk about some of the nuances of how to be able to incorporate these details and the time associated when it comes to hold downs here at our Scandinavian project. I'm sitting now in a covered patio space, and one of the things that's going to be typically discussed is the hold downs of how we're holding that framing or that structure down to the foundation. And typically we use an HDU, and we want it to be concealed within the building envelope. So in the past, we would go with, like, let's say a wet set that would sit on the outside of the stem wall, but we'd have issues with our stem walls blowing out. And so we've changed to an HDU, which provides an overall cleaner look to the aesthetic of our building. However, in this location, we have an HDU 8 that requires either an epoxy embedment all the way through the stem and into the footing, or we can have our engineer, civil engineer that is, come out and mark our building corners perfectly so we get our stem wall in place. So one of the benefits of working with a structural engineer is it allows us to be able to get essentially a better aesthetic with some of our hold downs. And since we're currently sitting at our project we're at the back patio, and what we have here is an HDU 8 to be able to meet the capacity for the structural load that'll be residing within this wing wall, as we have a cantilever beam that meets our ridge detail to help this modern masterpiece come together and provide additional shade in the summertime on our patio. But without going into too much detail, the additional engineering, while gives us a better overall aesthetic, there's some pieces of the puzzle that have to take place on site. In this case, we have two specific details for our HDU 5s and our HDU 8s. And one of the main reasons that we're utilizing a larger anchor is so that we can be able to anchor the framing members to the foundation based on the structural calculations required for potential uplift within this area. And while we don't have hurricanes in some of the other areas like tornadoes and such, we still have some pretty decent monsoons and storms that could have microbursts of over 115 miles an hour. And so we want to make sure that our structure is affixed appropriately to the ground. So as we look at this detail, we have a few things that need to take place in order to be able to pull it off. The first is having our civil engineer come and mark our specific building corners so that our stem walls are appropriately placed, so that we can be able to measure inside that wall cavity exactly where our anchor needs to go. As you'll see in the detail, we have a 6-inch embedment in the footing, which helps us to be able to avoid a larger embedment, such as let's say a 22 or a 24-inch embedment. And the main reason that that becomes more difficult to do is because you end up drilling an epoxy set anchor, and there's a lot of rebar that's within the structural detail of this stem wall. And so by having the engineer come out, mark exactly where our stem wall goes, and get our outside form in place, it allows our framers to come in and coordinate with our concrete company to ensure that that HDU 8 is embedded 6 inches into the footing and perfectly centered in alignment where it needs to be for our framing members to be attached. After which we'll be able to put our additional form board on the inside and move forward with the remaining of the anchor being wet set within that concrete form. So when we talk about some of the complexities of engineering, what does this mean to the overall scope of the project? Well, we have a few additional professionals that we have to schedule to make this all come together, and it typically adds somewhere between maybe 3 to 4 days to the overall process when including this more concealed and aesthetically pleasing anchor into your custom home. In order to execute an engineering detail like this, we have to have a great team that comes together that allows us to coordinate the necessary pieces that allow us to be able to make sure that this house is structurally sound, but also aesthetically pleasing. And that's what we've been doing for the last couple of years here at Rebuild the Block to improve on our overall build quality. And it's something that helps us to stand apart from the rest within our market to create something that's a truly custom home, regardless of whether it's a spec development or for a client. We appreciate you following, and as always, have a great day.